Welcome back to the deep dive. Today we are jumping into something that powers literally everything we do, Canada's energy systems.
It's so fundamental. I mean, we call it the lifeblood of civilization. And that's not an exaggeration. Everything from your phone to our hospitals relies on it.
It really is. And for the professionals, the engineers and geoscientists in Canada, the challenge is just immense.
It's a dual mandate, isn't it?
Yeah,
They have to keep the country running, keep this huge economic engine going, while at the same time leading this massive global shift to a low-carbon future.
that's the core of it right there. And that's our mission for this deep dive, to really get into how they manage that. How do you balance economic growth with, essential environmental protection and social well-being?
And it's not just about keeping the lights on anymore. The goal now is to completely reinvent the system to be cleaner, safer, more resilient. It takes more than just technical skill. It demands incredible ethical clarity.
And if you're working in a field this complex where the stakes are this high, understanding those foundational principles is everything.
Absolutely. So if you want to get a handle on the standards governing Canadian practice, make sure you subscribe right now. You'll want to hear more about the crucial NPPE exam.
Okay, so let's start at square one. The foundational role of energy. It's so easy to take for granted.
Oh, completely. Until it's not there.
Exactly. Without reliable and affordable energy, a modern economy just stops. Transportation, manufacturing, all of it grinds to a halt.
And that's where the professional responsibility really kicks in. Engineers and geoscientists are, in a way, the guardians of that reliability.
Yeah.
Their job is to make sure energy is produced, transmitted, and used safely, efficiently, and sustainably. That's the trilogy.
And Canada's role in this is just huge. We're a massive producer and exporter of, well, almost everything. Oil, gas, hydro, uranium.
And now a rapidly growing renewable sector.
Yeah.
And that global position means Canadian professionals are setting standards for the rest of the world. Their approach to, say, responsible land use or habitat management in a huge resource project, that informs how it's done everywhere.
That leadership doesn't just happen, though. It's born from innovation. So let's talk about the engine of all this change. Research and development, R&D.
Right. This is where science stops being theoretical
Yeah.
and starts becoming a real-world system.
So what's driving the R&D right now? What are the big goals?
It's pretty focused. The main objectives are, first, to drastically cut greenhouse gas emissions, second, to boost energy efficiency across the board, and third, and this is a big one, to develop totally new ways to store and convert energy.
Okay, here's where it gets really interesting for me. The specific tech. We're talking about renewable systems, right?
Yeah.
Solar, wind, tidal.
For sure, but also the other side of that coin, energy storage. You can't have large-scale renewables without it. So that means advanced batteries, yes, but also things like hydrogen fuel cells and massive grid-scale solutions to handle that intermittency.
And you can't talk about low-carbon energy in Canada without mentioning nuclear.
Not at all.
Yeah.
And the R&D there is fascinating. We're seeing huge advancements beyond traditional reactors toward what are called small modular reactors, or SMRs.
SMRs, we hear that term a lot. What's the big promise there?
The hope is safer, standardized, and much more flexible power. They could be perfect for remote communities or industrial sites that can't connect to a huge grid.
And what about the conventional side? Is R&D still happening with fossil fuels?
Oh, relentlessly.
Yeah.
It's all focused on cleaner extraction and refining and, the big one, carbon capture, utilization, and storage. CCUS.
Right. And tying all of this together is the smart grid, using AI to make the whole system more efficient.
Exactly. And Canada's a real leader here. Institutions like the NRC, NRCan, CNL, they're pushing the boundaries. The work on CCUS is a perfect example of engineers and geoscientists working together, and our deep history with the CanDu reactor is feeding directly into these new SMR designs.
So if R&D is the blueprint, let's walk through how a project actually gets built. How does an idea go from a geological map to, well, turning on a light switch?
It almost always starts with the geoscientist. The first stages are exploration and feasibility. That means geological surveys, seismic studies, all sorts of complex modeling.
To see what's actually down there.
To see what's down there, what the quality is, and what the initial environmental impact might be. They have to ask, is this resource even viable economically and environmentally?
And once they say, yes, it's there.
Then you move into the heavy engineering phase,
Yeah.
design and development. And this is truly multidisciplinary. You have experts in thermodynamics, fluid mechanics, material science, electrical systems, all working together.
We're not just talking about textbook stuff here. We're talking about applying those principles to build something that has to work safely for decades under incredible stress.
Precisely. And if we look at production, even conventional systems have been transformed. Geoscientists still find the reserves, but the engineers designing the pipelines and refineries are now laser-focused on cutting emissions and minimizing land use.
Meanwhile, the renewable portfolio is just exploding. Hydro is still the king in Canada, our biggest renewable source.
Yeah, providing that stable, low-emission baseload power.
But wind and solar are growing so fast.
Yeah.
And we're seeing other things like geothermal and biomass starting to get real traction.
One of the most interesting trends, I think, is the move toward hybrid and distributed systems. It's a kind of decentralization.
So not just one massive power plant.
Right. You have small-scale units, solar on rooftops, microturbines that complement the big plants. It makes the whole system much more resilient if one part fails.
You know, a key role that often gets overlooked is the geoscientist's job after a site is developed.
Yes, their work in environmental stewardship is critical. They're doing continuous monitoring of things like groundwater and soil quality. And they're the ones leading the studies on carbon sequestration finding and managing the deep underground formations where we can safely store CO2.
Okay, let's shift gears a bit. Let's talk about the ethical weight of all this, the energy-environment balance. For a long time, more energy meant more damage. The goal now is to break that link.
To completely decouple them. And that requires very specific professional tools. For example, any major project now needs a comprehensive life cycle analysis, an LCA.
Looking at the entire system.
The entire system, from how the raw materials are mined to how the plant is decommissioned and the site is reclaimed. There has to be an ironclad plan for rehabilitation.
This renewable transition, it's not just swapping out a coal plant for a wind farm, is it? It feels like a total societal transformation.
It is. Professionals have to design systems that do everything at once. Reduce carbon, keep the grid reliable, keep energy affordable, and help communities diversify their economies. It's a monumental task.
Which brings us right to ethics, the core responsibilities.
And number one, always, is public safety and welfare. These are high-risk projects. The potential for leaks, explosions, radiation, it's inherent. So upholding rigorous safety standards isn't just about following rules, it's a moral imperative.
And you can't have safety without trust, which means transparency.
Exactly. Professionals have to be completely honest about the risks and the environmental impacts. If the public doesn't trust the data, the project is a social failure, no matter how great the engineering is.
And that must create tension sometimes, right? Advocating for what's best in the long run versus short-term economic pressure.
Every single day.
Yeah.
That's a core part of sustainable decision-making. Advocating for the long-term societal good, even when it might conflict with, say, a company's quarterly earnings report.
There's also a huge social component, especially in Canada. Indigenous and community engagement.
It's absolutely critical. Respecting Indigenous rights, incorporating traditional knowledge, ensuring genuine partnership. It's not a nice-to-have, it's a fundamental requirement for any project to proceed ethically.
These aren't just abstract ideas. We can see them in action.
Yeah.
Let's look at a few Canadian examples.
For sure. Take the CanDU reactor program. It's known worldwide for its safety profile and its ability to use natural uranium. That's decades of Canadian engineering setting a global benchmark.
Or look at Alberta's oil sands, the development of Tacity.
Steam-assisted gravity drainage.
Right. That technology was a direct result of R&D trying to solve a huge problem. How to get that heavy bitumen out of the ground with a much smaller surface footprint than traditional mining.
It was a game changer for reducing surface disturbance, and then you have a massive utility like Hydro-Quebec, which is basically a global model for clean, stable power, and they're constantly researching grid modernization and energy storage.
So looking ahead, what's on the horizon? What's the next big thing?
A few things are really accelerating. The hydrogen economy is one. The challenge now is developing reliable, large-scale methods for making green hydrogen using electrolysis powered by renewables.
And you mentioned SMRs and CCUS earlier. That combination seems powerful.
It really is. SMRs for flexible, remote power, and CCUS for capturing emissions from heavy industry that can't easily electrify. That's where engineers and geoscientists will be working hand in glove, managing huge volumes of co-euros for safe, permanent underground storage.
And the digital layer over all of it.
The digital layer is transforming everything. AI and data analytics allow for predictive maintenance on a wind turbine before it fails, or optimizing power distribution across a city in real time. It's making the whole system smarter.
But I think the most important commitment for the future, and this ties back to ethics, has to be energy equity and accessibility.
I couldn't agree more. Technical brilliance means nothing if it doesn't serve people. Future systems have to ensure that clean, affordable energy reaches everyone, especially remote, northern, and indigenous communities. It's a matter of social justice.
So at the end of the day, it's this unique combination of technical mastery, ethical responsibility, and constant innovation.
That's the core of it. That's what a professional in Canada's energy sector embodies. They are fueling sustainable progress for everyone.
And that, I think, is the real challenge for the next generation. The question isn't just how we generate energy anymore, it's who benefits from it. And how quickly can we achieve true energy equity while upholding the incredibly high standards we've been talking about today. That's something for you to really think about.
Thanks for joining us on this deep dive. If you want to make sure you're ready to meet those high standards of safety, ethics, and technical excellence, you should definitely subscribe.
Subscribe today to hear more from us and prepare for success on the NTPE exam. We'll catch you on the next deep dive.